When we talk about a confidence interval, we've talked about the critical value and how that's associated with the amount of error that we're going to allow for the estimate or the guess that we're trying to produce. We're going to talk about this thing called the margin of error now. And here's what happens. On this normal curve, remember, we're trying to estimate the true mean value. And we know that the mean of any normal curve sits in the middle. And we're going to assume that our mean is what x bar is. Now, is our x bar the actual mean value? We don't know. We're trying to guess that. We're going to give ourselves this interval range, though. And the interval range was based off of what we call z stars, critical values, right? And z stars are just standard deviations above or below the mean. In this case, the right-hand z star we're calculating, so it'll always be above it. But we're going to place these bounds around it. Now, the value that sits from the center to the z star, the center out here, to the value out here is called the margin of error. It's the allowable error that we're going to give ourselves between the statistic and the parameters trying to estimate. If the margin of error, if it falls within the margin of error, then we'll say again, this falls in the safe region. If it's outside, it's in the rejection region. So we want our margin of error is going to help us decide what falls on the inside and what falls on the outside. The formula for the margin of error, which we call E. E is our margin of error, is equal to, and it's made up of our critical value, Z star, times the standard deviation. Remember, standard deviation is basically how far away from the mean, or the on average deviation away from the mean. So we're using that as an error measurement, and it's divided by the square root of n. This right here is what we call the standard error. This is actually the standard error of the sample mean. So we're going to use that to help create the margin of error. And here's an example. It says, a researcher is interested in the number of hours worked by employees at a large grocery store. The average number of hours worked by a random sample of 40 workers was found to be 29.6 with a standard deviation of 7.9. Find the margin of error at the 95% confidence level. So in order to find the margin of error E, we need to have a Z star, which comes from a confidence level. So this is your confidence level. It's going to give you this. And in our case, our confidence level is this 95% confidence level. We need a population mean, a population standard deviation, to find that. And we also need a sample size. So in this case, we have all these values given to us. Let's go and identify what they are. We know that the 40 workers is your N. So your N is equal to 40. We know that the standard deviation is 7.9. So sigma equals 7.9. To find the 95% confidence level, or the Z star that's associated with that, we know that we do Z star is equal to inverse norm. And remember, we're going to draw a curve. And on the inside of this curve, we want what percentage? 95%. How much is on the outside to this side? Well, 95 is on the inside. That means it's 5% on the outside. Just split it amongst two tails. So this is 2.5% on this side. And we're going to calculate this using the inverse norm function. So 2.5 plus 0.95 is 0.975. And again, we don't need to put a mean or a standard deviation because it's z-scores. So we leave mean and standard deviation 0, 1, which your calculator automatically defaults to. And this will be equal to 1.96. And now to find E then, E is equal to Z star, which is 1.96 times sigma, which is 7.9, divided by the square root of 40. And that'll be equal to I get 2.448. So that's the margin of error. And what that means is that we're going to have 2.448 on this side and 2.448 on that side as well. It's the allowable margin of error. Anything bigger than that is going to fall into our rejection region. If we rearrange the margin of error, we can actually find what's called a sample size calculator. Sample size calculators are used to give you the sample size needed for a desired margin of error. So let's say you want to be plus or minus 3% within your margin of error. You can find the actual sample size you would need based off the statistics given to you to calculate that actual value. And so if you rearrange, you're going to get a formula that looks like this. So all we did was we took the margin of error formula, which looks like this. Margin of error is E is equal to Z star times sigma over the square root of n. If you rearrange this formula, you're going to get this formula right here for the sample size. So all you did was you solve for n, and now you get sigma times Z star over E squared. So here's how this works. An English professor is attempting to estimate the mean number of novels that the student body reads during their time in college. He hopes to have a margin of error of 3 books with 90% confidence. From previous studies, he will assume that the standard deviation is known to be 10 books. This says, find the how many students should he survey? So what we're going to do now is this. We know a couple things already. First off, we know that he wants to be within 3 books for his margin of error. So this right here, this 3 books, is going to be your margin of error. And for the formula to work, you have to have an E, and our E in this case is the 3 books. You need a standard deviation. When they tell us that the standard deviation is 10 books. And then you also need to find a Z star. And again, your Z star comes from the confidence level. So our confidence needs to be 90%. So in our calculators, again, you can draw it out. You want 90% to sit on the inside. So how much is not on the outside? So how much is on the outside? 10%. But it's split amongst 2 tails, so that's 5% to this side. So in your calculators, you're going to do for Z star, this is equal to inverse norm, 0.95. And that'll give you 1.645. So for this particular problem, what we're going to do, n is equal to sigma, which is 10, times Z star, which is 1.645, divided by E, which is 3. And you're going to square all of this. So we get 10 times 1.645 divided by 3. Square all of that. I get 30.066. Now, the problem with that is this. You want to be within this number. If you use this value right here, 30.066, first off, can you have 30.066 people to survey? No, that's a problem. To make sure that we're always within this number, and the fact that we're dealing with a discrete number of people here, or a countable number, you always have to round this number up to the nearest whole number. So 30.066 rounds to 31 total people. No matter what that number is, you're always going to round it up. If you would have got 30, it still rounds up to 31. Because you want to be within. And remember, if you don't round up, you'll be sitting at the bounds. Kind of like in the histogram, you're sitting at the end bound if you didn't round up. You have to always round this number up to the nearest whole number.